Okay, here we are at the logarithmic functions, which now that we are all experts at exponentials, we should be able to deal with logarithmics pretty easily, hopefully. Fingers crossed, right? Okay, so the definition of a logarithmic function is simply the inverse of an exponential function. So if you remember, an exponential is y equals a to the x. And if we wanted to do the inverse, we're just going to switch the x and y. The a will stay where it is. So you get x equals a to the y. Now what happened is, us mathematicians, we like to have the y be equal to something in terms of x. And so what do we do when the y is up here as the exponent? Well, somebody thought of the idea of creating a new way of writing that, and they called it a logarithm. So it is defined, if you have x equals a to the y, it is defined as y equals the log base a of x. And that's exactly how we're going to say it. Y equals log base a of x. All right, now before we go any further, let's just go through some of these stipulations here. First of all, x has to be positive. What that means is that you're never going to take the log of a negative number. Second thing is that a has to be positive and a cannot equal 1. Okay, so these two come from how we originally restricted our exponential function. Okay, so let's go back to how do we remember what goes where? Well, first of all, when you have an exponential, this number a is your base. Okay, so that's the base of an exponential. Well, it happens to also be the base of your log. So that's kind of an easy thing to remember. The base is always the base. The next thing that you can remind yourself is that this exponent is what your log is supposed to be. So a log always equals an exponent. Okay, so this exponent that you see in your exponential is going to go by itself and then equal to your log. You have your base, and then the remaining number, because you've already used these two, this number is what you're taking the log of. Okay, so let's practice. We have to get good at going from exponential to log and from log to exponential. So if we have 16 equals 2 to the 4th, that's in exponential form, and we want to write it as a logarithm. First thing we're going to do is we're going to say that our exponent right here of 4 is going to equal the log, and since this was the base of our exponent, or exponential, sorry, we're going to have log base 2, and then this was the number that was left over, so of 16. So 4 equals log base 2 of 16 is an equivalent form of this exponential that's written as 16 equals 2 to the 4th. Okay, I'll have lots of practice with that. Let's go to graphing. Let's see what the graph should look like. If we have y equals log base 3 of x, unfortunately our calculator does not calculate log base 3. So we can't just plug in values of x and get values of y. But what we can do is we can take this and convert it into an exponential. So we know that 3 is our base, and this is the exponent. So we can say 3 to the y should equal x. And now we can come up with a table of values. The thing is, you can't plug in values of x to get values of y, but we can plug in values of y to get values of x. So let's do that. If we plug 0 in for y, we're going to get 1 for x. All right, well, let's place that on here. If we go over 1 for x, we're going to go up 0 for y. Oops, I need the bigger dot. There we go. Okay, next, let's plug 1 in for y. And so we should get 3 for x. So now we go over 3, and we're going to go up 1 for y. I know it's a little weird because of the order that we are plugging things in. Don't think that this is x and that's y. All right. Next, 2 gets us 9. So if we go over 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, I'm just kind of estimating it's going to be up there. Okay, so let's look at the negatives. If y is negative 1, that means we get 1/3. Well, we're going to go down to these little dots now. Okay, so if we go over a third, we're supposed to go down 1. So kind of right there. Okay, and then next, if we did -2, we get get a 1/9. Well, that's just getting closer to 0. So that's going to be like right here. Okay, so hopefully you guys can kind of see how this is going to go. Whee. Oops. Okay, that just sucks. Sorry. I'm going to do this and erase that. Okay. Let's see if I can do this better. There. Huh, much better. All right. So if you notice here, this is approaching y equal to or x equal to 0. So we're approaching the y-axis. So right there is going to be our asymptote. So if you recall, in the exponential graphs, our asymptote was the x-axis. Now with logarithms, our asymptote is going to be the y. And it's not always going to be the x and y axis, right? Because it can shift left or right, up or down. But notice that this is always going to be vertical, whereas your exponential is always going to be horizontal. Okay, moving on. Let's get some practice here. Remember, your log equals your exponent. So this is your exponent, 5. This is our base. So if we need to write this in exponential form, we're going to do 3 to the 5 is going to equal your 243. Okay, let's try this one. So here's our exponent. There's our base. So we do y to the x is going to equal 10. This is all you're doing. You're just converting into exponential form. What if you needed to write it into logarithmic form? Okay, so remember this right here is y. This is your base. So we're going to say 2 is equal to log base 6 of 36. Let's try 15 equals 4 to the n. So this is our exponent. This is our base. So we have our exponent equals our log base 4 of 15. And sometimes they're going to ask you to solve for a variable, like figure out what y is. So if we have log base 3 of 27 equals y, well, we can't plug this into the calculator. But what we can do is we can convert this to an exponential. So we have 3 raised to the y equals 27. And so you can either ask yourself, what do you raise 3 to get 27? Or you can rewrite 27 as 3 to the 3rd power. And since they both have the same base, then we know that y equals 3. That process is going to be more useful over here when we have y equals log base 27 of 9. Because when we convert this into an exponential, we have 27 to the y equals 9. And now these don't have the same base. And there's, you can't say 9 equals something here squared. So 9 raised to something is not going to be 27. But both of those can be rewritten to have a base of 3. So 27 is 3 cubed, so this is going to be 3 to the 3y. 9 is 3 squared. So now, since they both have the same base, I can equate the exponents. So 3y equals 2 and y equals 2/3. So that's a really handy little trick there. Okay, let's move on. Find y once again. Okay, let's convert this into exponential form. So this is our exponent, this is our base, so 2 to the 6 equals y, and now you can just figure out what 2 to the 6 is, right? What about the next one? We have to solve for x, so this is our base, this is our exponent. So x cubed is equal to 125, take the cube root of both sides, and we get 5. Okay, so what if you needed to simplify a log? It didn't say to solve for a variable, it just asked to simplify. Well, there's no equal to something here for you to convert it into exponential form. But that doesn't mean you can't add that in there, right? So let's just say y equals log base 2 of 32. We're going to try to solve for y, because that would make this in simplified form. Okay. Okay, sorry for that interruption. My niece and nephew just walked in on me. Okay, so where were we? Let's see. We converted this so that we had y equal, y equals log base 2 of 32. So now we can put this in exponential form. So we have 2 to the y is equal to 32. And now we can say, oh, well, you would raise 2 to the 5th power to get you 32. Alrighty. So, a common log. Well, a common log is basically just a log whose base is 10. And we use common logs quite often. And actually, your calculator has a log key on it. So if you have your scientific calculator out, look for your log key. And basically, that's just the key that you would use to evaluate the common log. Okay? A lot of times, the common log, we don't write the base 10. So if you ever see a log without a base written, it's implied that the base is 10. So on your calculator, figure out how you would input your numbers. The common log of 4.2 should come out to be 0.62324, so-and-so, keep going, right? And if you tried to take the log of -2, what happens on your calculator? You should get some error message, right? Because you can't take the log of a negative. Okay, moving on. Basic properties of logs. There are some 5 basic properties that you need to be aware of for logs, and this will make simplifying them a lot easier and faster. So we're using any old base a, as long as a is, positive. So the log base a of 1 is going to give you 0. And by the way, you can test all these and see where they're coming from by converting them into exponential form. So a to the 0 should equal 1, right? Okay, so log base a of a, well, that should just be 1. A to the 1 equals a. Now we have log base a of some number that has an exponent itself, and that number's base is the same as the base for your log. So these two numbers have to be the same, and then you're raised to the x power. Well, that just simplifies to x. Is that kind of cool? Same thing over here if you have an exponential where you have your base a raised to the log base a. So the exponent of your number is in fact a log itself, and they both have the same base. Well, it's like they cancel out and you get x. And then here, if log base a of x equals log base a of y, so basically these are both the logs with the same bases, then x and y have to be the same thing. Okay, so let's test this out. So here we go. They ask us to evaluate or simplify. Log base 2 is 64. So if you didn't want to write this as equal to y and then convert it to an exponential, what you could do is you could just rewrite 64 to have a base of 2. So you could say, well, this is log base 2 of 2 raised to the 6th power. And so now using this property right here, we know that this is just going to equal 6. Over here, this one, you don't need to rewrite anything, but it's using this property. 3 raised to the log base 3 is 4. Okay, so these properties can make things a lot easier for you. Okay, so really quickly, what is a natural logarithm? Well, a natural logarithm coincides with the natural base. It is a log whose base is e. We talked about e in the last section, right? Now, because the natural log is found in so many different places in the world, nature, just anything in science, they shorthand it to the ln, which you would think log natural log, it's just backwards. So the natural log of x, okay, and our restriction is that x has to be positive. Now this is just a notation that's going to throw you off, so just really try not to let that throw you off, okay? So let's look at our properties. The natural log of 1, these follow the same properties that we just talked about. The natural log of 1 should be 0. The natural log of e is 1. So remember, this could be rewritten as log base e of e, or log base e of 1. Natural log of e to the x, well, this could be written as log base e of e, to the x, so that's just going to be x. And then if the natural log of x equals the natural log of y, well then x equals y. So let's practice. So you had to evaluate the natural log of 1 over e. Well, 1 over e could be written as e raised to the negative 1. So using this property right here, natural log of e raised to a power just equals the power, that's going to equal negative 1. Natural log of e squared, well, once again, that's this property. We just get 2. If we look at this, 5 times the natural log of e, well, the natural log of e right here using this property is equal to 1. So 5 times 1 is 5. And I put this in here because your calculator also has a natural log button. So wherever your e to the x button is, that's probably where your natural log button is. You might have to do a second function, I don't know. But let's see if you can evaluate the natural log of 6, and you should get 1.791759 dot dot dot. I forgot to put the dot dot dot. Okay, sorry that this was such a long video, but there's a lot of information with logs, and I wanted to give it all to you with lots of examples, so hopefully it won't be too bad. Okay, make sure you ask questions in class the next day when you're working on these things if you're still confused. All right, good luck!